I'd like to introduce Mr. Pekka Lundmark and the CEO of Nokia. Well, welcome, Pekka.
Well, thank you very much. It's really great to be here. I want to talk to you today about the metaverse, specifically the industrial metaverse. And this naturally will mean talking a lot about technology, but it also means talking about business. Because our view at Nokia is that no one company can create all the elements required for the metaverse alone. No one can own the metaverse. It needs collaboration to build it, to create solutions and value so that collectively we can solve the big global challenges. And as we all know, these challenges are really big. Energy, climate, productivity, need to grow, need to provide more opportunities for more people, equal access to healthcare, equal access to education, equal access to jobs and so on. But before I take out the crystal ball and start making predictions about the future, I want to actually take you back in time to 1883, when the Brooklyn Bridge was built. Every time I pass over the bridge like I did this morning, I marvel at the feat of engineering it took to build what was the world's longest suspension bridge when it opened. It was actually a Tandon alumni, Arthur V. Abbott, an assistant engineer, who created the coupling system to make the cables strong enough so that the bridge could be built. And this got me thinking, how would you approach the design, construction, and maintenance of this iconic New York landmark if you were starting out today? Well, you would use autonomous underwater vehicles equipped with sonar and laser sensors to survey the East River and riverbed. A 3G digital model would help visualize the design and sell the vision to New York City's Department of Transportation. And let's say, if we are optimistic, you got the green light within a year or two. By then, it's likely that a substantial part of this new Brooklyn Bridge is going to be designed, constructed, and maintained with the help of the enterprise and industrial metaverses, as Nissan just explained. Let's take the 3D model one step further. You create a digital twin. A fully virtualized representation of the physical bridge down to the last detail. You input all the necessary data points to plot the life cycle of the bridge from the very beginning to 50, even 100 years into the future. Then you can plot traffic flow from Monday morning through Sunday evening. You can model what would happen if you replaced a vehicle lane with a cycle lane, or even 2 or 3 cycle lanes. And then you could even predict what would happen if a once-in-a-century hurricane struck the city. The enterprise metaverse would enable you to bring together all the different players, wherever they are based in the world, to collaborate and co-design a virtual bridge. Then large sections of the physical bridge would be prefabricated off-site in factories using AI-powered autonomous systems operating within the industrial metaverse. The industrial metaverse would also enable construction crews to work faster and safer through the remote-controlled robots and different types of exoskeletons. Contractors would have augmented and virtual reality tools, as well as real-time data on changing environmental conditions. The 19th century Brooklyn Bridge took 14 years to build, and at least 20 people died building it. Now the 21st century bridge could be completed in a third of the time with a target of 0 fatalities. And once that bridge is built, the metaverse would also help with maintenance. What if we could put sensors in every cable at every stress point so that authorities had real-time data on traffic, weather, load bearing and corrosion, giving them the ability to detect issues and fix faults faster, targeted predictive maintenance, actually to save lives. And don't forget, you've still got your digital twin of the bridge. With more advances in robotics and drone technology, eventually you won't have to put a human up a road to fix a fault. You'll be able to do it all remotely. So every action in the digital world will have an effect in the physical world, and vice versa. That is the full expression and the destination point of the metaverse, and actually all three metaverses: consumer, enterprise, and industrial. The enterprise and industrial metaverses will interlink. A single product from the same company will pass through both as it moves from drawing board to the factory door. And actually, to make it very simple, enterprise metaverse is where you design, industrial metaverse is where you manufacture or make. So in time, as IT systems in headquarters merge with OT, operational technology systems on the shop floor, these distinctions will actually blur. But for now, we think it makes sense to refer to them separately. Okay, so between Nishant and I, we have covered the three main metaverses and how they will evolve out of the two broader trends towards digital physical fusion and human augmentation. The metaverse's emergence won't be dependent on a single device or piece of hardware. Rather, it will be the combination and evolution of complementary technologies, including cloud and edge computing, AI, blockchain, very importantly, and the Internet of Things, of course, AR, VR, and digital twins. It's a given we will need more powerful networks. But how much more powerful? One of the leading voices of the metaverse, Matthew Ball, says in his book, The Metaverse and How It Will Revolutionize Everything, is the name of his book, that a key characteristic of the metaverse will be the ability to render 3D virtual worlds in real time with an unlimited number of users able to experience them synchronously. Did you know that to date the world's largest virtual event was Fortnite Galactus on December 1st, 2020, with 15.3 million people online at the same time. Now, that was not even a truly synchronous experience. And it was one game, it was just one game, an entertainment experience. By 2030, we estimate that every physical thing that makes sense to connect will be connected. And I'm not talking about putting chips in people. I'm talking about people willingly opting in to share data from their smartwatches, wearables, smart glasses, and even contact lenses. It's also machines talking to one another. It's digital sensors in physical infrastructure like roads, railways, and yes, that high-tech Brooklyn Bridge. With all that increased data and increased need for data processing close to the edge, networks will have to deliver 100 gigabits per second, sub-millisecond latency, even higher reliability in certain instances, perhaps as much as 7 nines. As we move from 5G to 6G, with more businesses carrying out at least some of their operations within the industrial metaverse, networks will need more capacity and faster speeds. And they will also need to become more resilient, agile, and intelligent, using AI and machine learning to support a wide array of mission-critical functions. And with so much sensitive and highly confidential data from individuals and companies flowing through networks like water, we need to make sure that there are zero leaks. Web 3.0 and decentralization may help provide the necessary trust. At Nokia, we are already building our products with a zero trust approach, baking in security from the chipset level up. So we need trusted networks that can meet the performance needs of the metaverse and the digital world more broadly, but with zero compromises on security or reliability. We need future-ready performance because no one has a crystal ball. No one can predict the exact details or what the most successful metaverse applications will be. But by talking to our consumers and partners, and through years of work by Nokia Bell Labs, we can make informed assumptions about the broad shape of the metaverse and the technology requirements. We believe that without future-ready networks able to provide seamless and scalable connectivity to meet future needs, the metaverse we are all hoping for will remain science fiction rather than science fact. Anticipating future needs is a major component of our work at Nokia. A good example of this is passive optical network trial that we did with Vodafone last year, where we achieved record-breaking speeds of up to 100 gigabits per second, which is actually 100 gigabits per second on a single wavelength in a passive optical network. This is up to 10 times faster than many of the most advanced networks available today. We are also continually pushing the boundaries of 5G, such as our 5G millimeter wave research with NYU Wireless. And we are playing a leading role on 6G collaboration on both sides of the Atlantic with the NextG Alliance in the US and HEXA-X programs in the European Union. But before I focus on collaboration, I want to jump back into that time machine for a second and take you back to 1998 and a prediction about the internet from the Nobel Prize winning economist Paul Krugman. He forecasted the growth of the internet will slow drastically as the flaw in Metcalfe's law becomes apparent. Most people have nothing to say to each other. By 2005, it will become clear that the internet's impact of the economy has been no greater than the fax machines. It's easy to find that amusing now. I doubt that many NYU freshmen would ever have used a fax machine, whereas they are all, of course, carrying a mobile internet device. So making predictions is difficult. Making technology predictions is notoriously difficult. However, there are valuable lessons to be learned from the evolution of the internet. What took the internet from a government research project and academic network to the World Wide Web of the 90s, to so-called electronic mail, as it was called, to 3G mobile internet, to a 4G multi-billion-dollar app economy, to where we are today. It was shared standards, interoperability, that open foundation enabled different players to contribute different elements, telecom companies, technology firms, physical networks and devices, digital services and experiences. It was collaborative information by accident rather than design that make the internet one of the most impactful inventions in human history. As Matthew Ball says, no one company could drive end-to-end improvements in the internet, even if they operated the entire internet protocol suite. So, what lessons should be applied to the evolution of the metaverse? Number one, the metaverse can only achieve its full potential if we all drive industry standards on openness and interoperability. Nokia recently became a member of the Metaverse Standards Forum in order to drive industry cooperation on standards and protocols. We also need to ensure networks, the backbone of the metaverse, are open to established and emerging players so new ideas can be brought to life and we can all benefit from the gradual evolution and improvements to the metaverse. Number two, the metaverse can only achieve its full potential if everybody is invited to the party. We have seen the opportunities that come with internet access. And we have also seen the cost to countries and communities where there is no or limited internet access. Even today, 2.9 billion people in the world, around the world, remain unconnected. The World Economic Forum says that low-income countries, if they manage to increase mobile broadband levels by 10%, tend to see an uplift of GDP of around 2%. While the World Bank estimates achieving 75% internet access in developing countries would create more than 140 million jobs. If every action in the digital world is going to have an effect in the physical world, then it's critical we bring digital access to people, places, and industries not yet served. And number 3, if we want to maximize the potential of the metaverse, we need to focus more on the collaborative advantage. We need to ask, how do we bring 3, 4, 5, 6, or even more different players into an ecosystem where data can be shared securely, where new products can be created and brought to market? Looking back at the journey from 3G to 4G, tech startups founded in garages, they became some of the most valuable companies in the world by being first to scale and squeeze out competitors. But looking forward, as we move from 5G into 6G and digitalization comes to every industry, no one company can hope to create or own all the elements required. It won't be enough to secure a competitive advantage over one part because there will be too many different parts and different players involved. Think about it. Airports, schools, factories, hospitals, ports, energy grids, water networks, agriculture, healthcare, steelmaking, and even space exploration. There will be no corner of our physical world, pretty soon the moon as well, which will be left untouched by digital technology. If the metaverse is going to be the principal platform of the 6G era, where digital physical fusion and human augmentation combine, then it's clear no one can own the metaverse. We need collaboration to build it. Collaboration requires changing our mindset of only working with one partner at a time. Collaboration requires bringing more technical skills and different contributions into the mix while increasing business agility, to bring more solutions to the market, and to create more value for all the players involved. Putting rocket boosters under a new metaverse economy, an economy that Citi Investment Bank estimates could be worth $13 trillion by 2030, more than half of the US GDP today. That's collaborative advantage. And collaboration is Nokia's source code. We are collaborating with all the major service providers on next generation connectivity for homes and businesses. We are collaborating with hyperscalers like Amazon Web Services, Google Cloud, and Microsoft, taking telecom networks into the cloud and giving service providers and enterprises more choice and simplicity. We are collaborating with renewable energy leaders like Siemens Gamesa to digitalize energy networks so wind turbines can be monitored in real time and faults fixed faster, and so that weather-dependent electricity generation can be connected to the grid more efficiently. We are also collaborating with specialists like Kyndryl to accelerate enterprise digitalization. And through our partnership with Microsoft, we have integrated their Azure Arc product into our MX Industrial Edge platform to support a wider range of mission-critical functions for enterprises. This is by no means an exhaustive list, just a snapshot of our current collaborations. I should also mention that innovations from our vast patent portfolio are licensed on fair terms to more than 200 different companies, enabling devices and solutions a range of sectors because we recognize that we occupy a unique position. We bring together technologies and partners such as service providers, hyperscalers, industrial giants, app developers, and startups to drive innovation in new business models and applications to generate greater value for all of us. That's the collaborative advantage. It requires a foundation of trust and transparency, and it needs to be focused on the bigger picture. I'm talking to a room full of engineers now, and there's a lot of innovators here, so you know the network effect. Essentially, the more something is used, the more valuable it becomes. It was true for the internet. It will be true for the metaverse. What if we could harness the network effect to not only scale businesses and create financial value, but also to create solutions and create real societal value, to truly achieve impact at scale? That's the reason why we are so focused on the industrial metaverse at Nokia. This is the point I want to finish on. And to illustrate, I want to return to the idea of digital twins I started with. Here you can see an example of a digital twin or avatar in the consumer metaverse. He's the perfect CEO. He can work 24 hours a day. He can also run 10K in less than 30 minutes. And he is a Knicks fan when he's in New York. But on a more serious note, here is a digital twin for a power network showing the real-time fire risk to power lines from vegetation, one of the main reasons for wildfires. This is just an illustration, but the Australian company Fugro have created a prototype for TAS networks in Tasmania, Australia. Here's another example of a digital twin, an experimental nuclear reactor. The US Department of Energy's Argonne National Laboratory are using a digital twin as part of their research and development of a next generation nuclear reactor. And then the next one is digital twin of a human immune system. 200 scientists, led by teams from the University of Florida and Indiana University, have set out plans to create a digital twin of the immune system, saying it would be a major breakthrough for precision medicine and the treatment of diseases like cancer and COVID-19. There's been a lot of hype about the metaverse ever since Neil Stephenson coined the term in his novel Snow Crash. A large part of our work over the past decade has been focused on researching the underlying technologies of the metaverse, separating the reality from the hype. These examples from the 1.0 version of the industrial metaverse show that it is already enabling real-world solutions to real-world problems. The potential is so much bigger than we can imagine, bigger than any of us can predict. But whatever the future holds, one thing is for certain: we must continue collaborating so that, as Nokia's purpose statement says, we can create technology that helps the world act together. Thank you.